right, moving on. Day 2 and 3 is combined lesson because it's the same concept on similar polygons. So we talked about this when we talked about congruency, that there are some rules that didn't apply when we would be getting the similarity, and we talked about models and smaller versions of things. Polygons that are the same shape but not the same size are similar. We use this symbol for similarity. So, whoopsie, it's not that. It's a little wavy line. Can't get the board to respond. All right, there we go. Sorry about that. Similar polygons. Polygons are similar if corresponding angles are congruent and the sides are proportional, which means they have the same ratio, which goes back to lesson 1. So the angles are congruent and the sides are proportional. So how do we name similar polygons? When writing similar polygons, make sure the vertices are written in the same order, just like we did with congruency. So, ABC. So we're going this way and then that way. So we're going to go this way and that way. So ABC is similar to DEF. I don't know what's wrong with the board. All right. So the blanks are congruent, the angles are congruent, and the sides are proportional. We already talked about this. So on these two triangles, angle A is congruent to angle D. Angle B is congruent to angle E. And angle C is congruent to angle F. And the proportional sides, DE, order's important, is going to be the same as AB. What's the same as AC? DF. And when I say same, I mean proportional, sorry. DF. And what does that leave? Well, EF, and then BC, keeping the order the same. All right, determine if these are similar. Justify your answer. Well, this angle is the same, this angle is the same, this one's the same, and that one's the same. So we have congruent angles. Now we have to see if the sides are proportional. So we have to test 3 and 4.5. We have to test 2 and 3. And we have to test 5 and 7.5. And the quickest and easiest way to do this is just do the decimal trick we talked about in lesson 1. So if we take 3 divided by 4.5, we get 0.6 repeating. Hopefully you know 2/3 is 0.6 repeating. And 5 divided by 7.5 is 0.6 repeating. So the answer is yes. Why? Angles are congruent and sides are proportional. Okay? Let's check this one. Right off the bat, no. Angles not congruent. We're done. Even though 4 times 2 is 8 and 5 times 2 is 10, the sides are proportional. It has to be both equal angles and proportional sides. All right. Determine if they're similar. Write a similarity statement if they are. So, here we go. Now you got to be careful with this one because you got to think about this one kind of rotating it. So we have 120, 120, 60, 60, 120, 120, 60, 60. But you have to think about turning it. So the 7 corresponds to the 12. And the 5 corresponds to the 10. So let's think about that. Is 5 over 10 the same as 7 over 12? And clearly you can tell, no. Because this would have to be a 6 over 12 instead of a 7. So if these sides here were 6, we would have proportional similar shapes. But we don't, because the sides are not proportional, even though the angles are the same. This one's really tricky. Notice the markers. I suggest we turn it around. So I would suggest you take this one and put 2 here, 1 here, and like this. But the 1 is C, the 2 is T, and this is still A. So TC is 12, AC is 5, and TC is 13. AC is 12. Okay? It's very tricky, and I suggest rewriting it so you can see what's going on. Makes it a lot easier. So now we're comparing. S and T are the same, X and C are the same, and I and A are the same. So angles are good. Check. Now we got to check. 5 AC is to 20. 12 is to 48. And 13 is to 52. Well, we can turn these all in decimals, or if you see that 5 times 4 is 20, 12 times 4 is 48, and 13 times 4 is 52. Therefore, the answer is yes. But if you want to do it, 5 divided by 20 is 0.25. And if you do this one, you get 0.25, 0.25. So the answer is yes. Now you got to be careful with the letters. So SIX is similar to TAC. All right. Find the value of X and Y if ABC is similar to FED. So again, I personally like to do this and put F, E, D to match it up. Okay, so FE is my Y, DE is 12, and this is 15. Now, what does X have to be? Well, first off, you got to find what numbers you have on both. See, 5 corresponds to Y, that's an unknown. X corresponds to 15, that's an unknown. So my only numbers I have are 8 and 12. I like to call that my magic ratio. And I also like to do something like this, a word ratio, to keep on track. So 8 is my small, X is on my small, and what corresponds to X? 15. Now I'm going to do it again with my magic ratio. And Y is on my big one, and Y corresponds to 5. And now I just have to solve, cross multiply. So 12x equals 15 times 8, which is 120. So x is 12. Over here, 8 times y equals 5 times 12. And then 60 divided by 8 is 7.5. And those are the values that will make those two triangles similar. because the sides are proportional and the angles are equal. Real life, most movies are filmed with a 16:9 width to height aspect ratio, but TVs are 4:3. Show that these two are not equal. Well, you just do 16/9 equals 4/3. Now you have two choices. You can turn them both into decimals. So if you do that, you get 16 divided by 9 is 1.7 repeating. And 4 divided by 3 is 1.3 repeating. So you prove they're not equal. Or you can cross multiply and get 9 times 4 is 36. And 16 times 3 is 48. Again, not equal. So you have two choices there. Turn them into decimals or cross multiply. Now, in a movie on the big screen, the width is 20. So a movie is 16:9. 16:9. And remember, that's width and height. And I like to keep myself straight here. So the width is 20. How tall will it be? So again, multiply 16x equals 9 times 20, 180. And then when I divide 180 divided by 16, I get 11.25. So 11 1/4 feet. When you see the same movie on your TV screen, so TV is 4:3. 4:3. Again, width to height, which measures 2 feet tall. So that's down here, and our x is up here. So that's going to be 3x equals 8. And then I divide 8 divided by 3, and I get 2.6 repeating feet. If your TV screen had the same aspect ratio as the movie theaters, how wide should your TV screen be? So, 16:9, again, width to height. So now we're looking at the TV. We're trying to find the width. So my height is 3. So I'm going to do 9x equals 16 times 3, 48. And then I do 48 divided by 9. And I should have 5.3 repeating, or 5 1/3 feet. So that should be the height, if it was the same aspect ratio as a movie theater. Okay, example 4. Find the values of x and y to make them similar. So again, I'm going to turn mine around, RST, JKL. So I'm going to try to draw it kind of the same way. J, go in the same order, JKL. So LJ is x, LK is 7, and JK is y plus 2. I have to find my magic ratio. Where do I have numbers? So 4 to x, 5 to y plus 2, 6 to 7. There's my magic ratio. So I'm going to find x first. So 6 to 7. So again, I have my small and my big. So my x is on my large, the big one. It corresponds to 4. So I get 6x equals 7 times 4, which is 28. So I do 28 divided by 6, and I get x equals 4.6 repeating. Again, 4 2/3. Now I'm going to do it again. 6/7, small, big. Now my y plus 2 is on my big. And that corresponds to 5. So now I'm going to do the math. remember to put this in parentheses. So 6y plus, very important, 12 equals 5 times 7. I subtract 12, 35 minus 12 is 23. Then I'm going to divide by 6 and get y equals 3.83 repeating. Which would make that side 5.83 repeating. Okay, scale drawings are often used to represent something that's too large or too small to draw. Contractors use scale drawing or blueprints to represent a floor plan. So last thing here is actually example 5. In the blueprint, 1 inch is 16 feet. So 1 inch, 16 feet. Find the actual dimensions of the living room. So the dimensions of the living room are 1.5 by 1 1/4. Okay? So we need to convert those into feet. So again, 1 inch, 16 feet, 1 1/4, which is 5/4, or we do 1.25. How many feet will that be? So that's simply just 16 times 1.25. So that's going to be 20. Then we're going to do the same thing. So we're literally just going to take 16 times 1.5. This is 1.5 here. So 16 times 1.5 is 24. So the living room is 20 by 24 feet. Okay? And for part B, the kitchen is 1 1/4 times 3/4. So we already know what 1 1/4 is. So the kitchen is, why is the board not working? The kitchen is also going to be 20 feet. And then we just got to take 16 times 3/4 and get 12. And that's it.